All right, in this video we are going to work on the index of and contains methods in the linked list. All right, so first off, index of method, it returns an int and its parameter is object O. So we'll put something in here that we're looking for in the list, and then index of is going to return the first index of occurrence of the object in the list, or -1 if the list does not contain the element. So this is basically the search, similar to the problem search an array for a given element, right, and return its index where it's located. All right, so it's going to be public int index of object O. And again, you might wonder why I chose object there, right? That's so it would be similar to how Java implements it. So we could have used E there also, but that's okay. I'm just trying to make it a similar, these methods that are actually in the list interface in Java, than similar to their design. So okay, so what we're going to do, basically we don't have a whole lot of choice when we do this. We are just going to go down the list and just check to see if we find what we're looking for. So we have to start at the head here. That's the only way we can really access the list to begin with. And we're just going to look, hey, is this the thing we're looking for? No, then move to the next one. Is this what we're looking for? If so, then return where we're at, the index where we're at. If not, move on to the next one, and so on and so forth. Okay. Okay. So we're going to traverse the list of nodes. So we're going to need a variable for that. And I'm just going to call it node. And we're going to start at the head. And then we're going to have a for loop. So for int I equals 0, I less than size here. I plus plus. So that's basically like your standard for loop that you would use, say, to process an array, but instead of dot length, right, we're just using size because that's a field within this class, okay? And then inside there, we're going to have a statement if, and then here's where we're going to check, hey, is the element at this index, is that the one that we're looking for? So in order to do that, right, we can't use double equals here because this is object, right, and these is generic, so it's got to work for any reference type. So in order to do that, we're going to have to use O dot equals, okay, instead of double equals here. And so this is the thing that we're looking for. So is the thing that we're looking for, does it equal the element at node? Okay, so that would be node dot element. Does the object that we're looking for equal the element at the current node? Okay. Okay, so if it does, right, that means that we have found what we're looking for, the first occurrence of it, and so therefore we are going to return the index that we're at. So this variable I here is going to keep track of the index where we're located, and then we're going to return it, right? This method's over, no need to go any further, just return the index where we found it. All right, and then if not, right, if it's not, it's going to drop through here. We just need to move on to the next node. So if we start off here at the head, right, then we have to move to the next of that one. So we're going to change the value of the node. So move on to the next one. So the new value of node is going to be the current value of nodes next. So just go to the next one. So the current value of node, go to the next one, right? And that's going to be the new value for node. So that's going to keep going to the next one if I don't find what I'm looking for. Okay? So I'm slowly going to traverse the list looking for the element that I've been given. If I find it, I'm going to return the index where I found it. If not, I'm going to keep going. So it is possible that that element might not be in there, and you would get all the way through this for loop, and it would drop out here. If that's the case, right, then we're going to return -1 as a signal. Hey, we couldn't find what we're looking for. Okay. and I forgot a semicolon. Okay, so there we go. So let's test that out. We'll do system.out.println words.indexOf. Let's go m. Let's see. I can't remember what was in there. Let's do M, N, and B. And one more. So M, N, B, and then one that's not in there, let's say X. Okay, in the index of M, we should get 0. Index of N, we should get 11. Index of B, that's 0, 1, 2, 3, we should get. Index of X, we should get -1 because it's not in there. Okay. All right, so that looks good. Next up, let's go with contains. Contains, right, is a Boolean, so it's going to return true or false. All right, so we're given an object, and we're going to return true if that object is in the list, and we're going to return false if it's not in the list. So we've basically done all the hard work with index of. So for this one, we can just return index of O double equals -1. Okay. R is not equal to -1. Sorry. We're handed an object to say, hey, is this in the list, right? And then we go find the index. Let's say the index is 5. That means we found it, right, in the list. And so then it will do 5 is not equal to -1. That's true, right? So that means that's true. The object was in the list. And then let's say if we're looking for an object and we don't find it, right? Then index of is going to return -1, and so this will be -1 is not equal to -1, right? That's false, and so we'll get a false. That's the correct thing in there. So again, just calling a few calls on this one. We'll do contains on each of these. So we should get 3 trues and a false. There we go. Okay. All right, and just to run through one of these, because we failed to do that, so let's just run through this one here. All right, so words, system.out.println words.contains n. So if we step through this one, right, it's going to call in here. This calls the index of method with n as the element that we're looking for, right? That sets up node and it checks, right? And so it says, is that an n? No, it's not. So this moves us on to the next one. Is this an n? No, moves on to the next one. Is that an n? Nope. Moves on to the next one. Also, I has been increasing here as we go through. Right? Is that an n? Nope. Move on to the next one, increase I. Is that an N? Nope, I did the last one. So we keep cycling through here and keep moving on to the next one. And then here we go. Hey, we finally found, right, something that equals what we're looking for. So it's going to return the index. You can see the index there is 11. And so there we go. 11 is not equal to 1. That's true, right? And so there we go. All right, that is it for this one. In the next videos, then we'll take a look at the two remove methods.